Good evening. Am I audible? Is my screen properly visible? Yes, good evening. Dear participants, please confirm so that we can start with today's class. Good evening. So today we are going to see a new topic which will be natural language processing, which is an important application when you comes for its whatever maybe it is data science or machine learning. It is an important task how human language is processed by the algorithms. So we are going to see about it in today's class. Are you guys excited? Can we see about it? So today is day 18 of data science Naan Mudhalvan virtual internship, and I welcome you all on behalf of Pantech elearning. So today is day 18 and we are having 2 days left, which will be day 19 and 20. With that, this classes will be over. So that depends, learning one technology is best or learning many technologies. So if you learn even one technology, learn to the core, okay? So if you practice that very well, it will be very useful for you. Okay, so today we are going to see about natural language processing. And after this day 20, you will be having 10 days time for project. So actually you have to register for this project. That link will be circulated tomorrow, okay? And you have to register for it. So once you register, you can do it as an individual or you can do it as a team. So once you register, you will be having 10 days time from day 20 to 30. We'll be specifying the dates for you guys. So once you come in that time, you have to do that project. So it should be unique and it should be on the data science background. It should be, you try to give your best, and with the submissions, okay, you have to submit the project and it will be segregated and the winners will be selected and you are having prize money for this. So that link for registration will be circulated in tomorrow's class and day after tomorrow. Today I hope we will be circulating the assignment 3 update link, okay? So if you have submitted it, please update it there, okay? Please make sure you are submitting it. Clear? So today we are going to start with natural language processing. So as the name itself suggests, nowadays these chatbots or something like whatever we are talking, okay, the AI talks to us back. For example, like ChatGPT we are having, right? So you are asking something and it is giving you some response. So how it is doing it actually? Okay, you are asking something and it is giving you a response. So it understands or it tries to understand what you are telling, right? And compare with the past data. So how it is done? So that's what we are going to see in today's class. And the assignment 3 update link, guys, it is in the description below. So you can check it about the assignment 3 update link. So you can update it there, right? So I hope we can start with the class in natural language processing. So for natural language processing, it is like natural language or human language, we are going to process them. How we are going to do? There is a library for it. In Python, it is known as NLTK, which is nothing but Natural Language Toolkit, okay? It is a popular Python library used for NLP purpose to work with human language data. So it helps convert text into numbers. Actually, guys, when we see about machine learning or neural network, what we are doing actually, whether it may be a text data, okay, if you are having text data, you are encoding it and converting it to numerical format, right? We have done it machine learning. In CNN, we are passing the image, but what is an image? It is a pixel value which is nothing but numerical value from 0 to 255 in all the pixel places. So then we are processing it and giving it to the model or algorithm or neural network. So everything, whatever may be the input, we are trying to convert into numbers. And that numbers, when we give it to the machine learning model or algorithm, it can do the processing for us. Okay, so this NLTK helps us to convert them into numbers which the model can easily work with. So NLTK has tools such as tokenization, stemming, tagging, parsing, sentiment analysis, and so on. We are going to cover a few of the tools. So to install, starting with the install, you can go with pip install NLTK, and once you've done it, you can import NLTK. Okay, so you have to download some extra things. So first I'll go and initialize this because it may take some time for it to complete. So you can go with nltk.download all. So we'll repeat this in Google Colab and we are going to process this data, guys. So I have just created a sample. Okay, this is a paragraph which we are going to process. Okay, so I'll run this and keep it for further processing. For now we'll import or install pip install NLTK. So this will help me to install natural language toolkit, and once it is done I can go and import NLTK. Okay, so once you are starting, you better go with something, because when you try to run, some additional things are required to be downloaded. If you haven't done it, it will show you error. So that's why we are like doing it in earlier nltk dot download, and I'll pass this command all. Okay, it is going to download everything required. So see here, it is going to start downloading and zipping the packages which is required. This includes many types of text formats which will be very useful for us. We'll discuss that later. So this is going to take some time. In the meantime, we can go and check the next things, right? So the assignment update link is circulated in the chat box also. You can check it down and fill it. Okay. So we are going to start something known as tokenization. Can we start, guys? Can I get thumbs up? Are you guys there? Can we start with this tokenization? So this is the first step you will be doing when you are processing a text. It is in Google Colab. If you are installing it in Colab, it will be in that cloud, okay? So not on your system, that's why we are using cloud, Colab. If you are using any of your system ID, then it may store in your system. Waiting for your response, guys. Thank you. So I hope we can start. So this tokenization is the process of splitting a text into smaller units called tokens. Okay, so for example, in that Google Colab I have a long paragraph, right? So I'm going to split them into small parts. So that small parts is called as tokens, and this process is called as tokenization. So these tokens could be individual words, phrases, or even sentence based on what you are doing, what you require. Okay, by breaking down a text down into constituent parts, we can begin to analyze its meaning and structure. So if you are having a lengthy paragraph, you want to like split them into parts. That's what is known as tokenization, and that parts are called as tokens, that smaller units. So you have two options, guys. So for example, if you are having like in tokenization, we are having two options. One thing, if you are having a long paragraph, okay, you can turn them into sentences. What is a sentence? Combination of words. For example, this is a sentence. This is one sentence. Okay, you can break them into sentence, or you can go and break them into words. For example, you can take the individual words separately. So if you are having a lengthy paragraph, if you go for tokenization, this will be like, okay, you will be having different sentence. If you are going for sentence tokenization, if you are going for word tokenization, you will be getting like this. You will be getting a list with all the words individually separated by comma. Okay, clear about what is happening in tokenization? We'll see that practically. If you are having a paragraph, if you go for word tokenization, you will be getting words separately in that sentence or in that paragraph. If you go for sentence tokenization, it is going to take this sentence alone. So if you want to perform sentence tokenization, you can go with nltk.sent_tokenize. Clear, guys? So this will help you to convert a paragraph into sentences. It will be stored in a list separated by comma. If you want to convert them into words, you can go with nltk.word_tokenize, which will turn them into words separately. So I hope we can do this in Colab. So this is completed, guys. This download is completed. Now it won't show any error for you guys. If you skip this part, in Google Colab it will show error, but it will also show you to install, okay, or download that separate thing alone which are required. So you can do that at that time. So otherwise it will be better if you do it prior. So this sample is my So we'll discuss about that later because we are just starting with the NLTK. We cannot directly go into pre-trained NLP model. Once we complete the basics today, tomorrow and day after tomorrow, we are going to see projects based on NLP, where we incorporate RNN, LSTM, okay, those neural network for these kind of tasks. In that, I'll try to cover pre-trained NLP model. If you have that model, you can import and use it, guys. No issue. So first, I'll print this sample for you guys. So this contains a paragraph. You can see it. Okay, it is combination of sentences. It is a big paragraph. So what I'm going to do, I'll convert them into sentences. So sentences equal to NLTK dot sent underscore tokenize. Okay guys, I want to pass the sample inside. So I'll run this. So now I'll print the sentences. Print sentences. I got a list here. See here, this is the first sentence, comma, the second sentence. See here, this paragraph is now changed into a list with combination of sentences as its element. And now I can print the length of it. Print length of sentence. Totally 8 sentences are there. So I can go on for X in sentences. Print X, okay, and then I'll print something for R clarification. Okay, so each sentence is now separated. See here, this is the first sentence, this is the second sentence, and so on. Totally 8 sentences we got. Okay, this is what sent underscore tokenize is. If you want to convert them into words, you can go with words underscore tokenize. So words equal to NLTK dot word underscore tokenize. So I'm going to pass the sentence. You can pass the sentence or you can directly pass a sample, whatever it may be. Okay, so I'll print words. See here, I got the individual words. Climate change is one of, it is going to keep on going. All the words are now segregated. You can go and get the length of it. Print length of words. So in this we are having totally 2 to 7, and this also includes if there is comma or space, it is also going to be included as a sentence. See here, this is also considered as a word which can be later used. You can use a conditional statement to remove them. Okay, so I hope this tokenization is clear. Are we clear guys regarding sentence tokenization and word tokenization? Can we go on with next one known as stop words? Can we go guys? So now you are having a paragraph and you are converted into small parts or tokens into words. Now you want to remove the unnecessary words or like stop word or common English words which are like for connecting. Okay, they don't have any meaning, but for a connective colloquial term we are just using that words, and that words are not going to determine anything in our output, so we want to remove them. Okay, so for that we are going to use something known as stop words. So this stop words is from NLTK. It has some predefined words such as the, and, okay, and some of these repetitive words which are not carrying any importance in the sentence. Okay, so the stop words are words that occur frequently in a language and do not carry much meaning on their own. So this stop words is a package where you can store, they have it. Okay, so with this you can compare, and if your sentence have these words, you can remove them alone so that you can separately get important words. So stop words are often removed from text during pre-processing to reduce the amount of noise and focus on more important words in the text. So these words are available in NLTK stop words, and they can be used to remove in our data set. You can use the stop words to remove from your original data. So how to load this? From nltk.corpus import stop words. You can take it. I hope we can go and try with stop words, right? From nltk.corpus import stop words. Okay, so this stop words I want to load them. I'll store it in stop. Okay, so here I'm going to call stop words, and in that I want words. In which language? I need English. Okay, and another thing guys, I'll make it as a set. So why I'm doing, I don't want the repetitive words inside of it. It may have, so I'm going to pass it as a set. What is the property of a set guys? It won't allow duplicate values, right? So I hope we can print stop to see what it is there actually. What are the stop words? See here, has, isn't it? We, himself. You could have seen, right? What are the words is present in this stop words. Now what we are going to do? We are having our own like sentence where we convert them into words. So using a for loop, we are going to run this and check whether these words are in this stop. If it is there, I am going to leave it. Okay, I don't want the stop words. Otherwise, I am going to take that important words alone. Are we clear? So I'll create a list new. Okay, so in this I am going to append for y in words. What is this words actually? This words here. I have stored it, right? This list. Now I am going to iterate over them. So first I'll print y for you guys. Okay, so all these words are now running. So now what I'm going to do, see here, for y in words, if y not in stop, which means if it is not there, I'm going to append it in this new list. I'm going to append the y. Okay, so the stop words will be removed now. So now if I go and print new, it is going to give me the important words. So those repeating words will be removed. Okay, climate change, one, pressing, these are the important words now we got. Okay, clear? So this is what known as stop words, and it is a pre-processing. When you go for NLTK, it is important to do this process. Okay, first you will be converting them into tokens, then you will be stopping the unnecessary words. So next part will be stemming. So this is a process of converting. Okay, can we start guys with stemming? So stemming is the process of reducing a word to its base or root form, which allows different variations of a word to be treated as the same word. For example, the stem of word running and runner and runs is run. Okay, this is the base word, but these are like some different forms, right? So it will try to identify this one. So stemming is not always perfect. Okay, when you go for stemming, it is not always perfect, and it can sometimes result in a stem word which is not even a real word. For example, the stem of the word was is wa, which is not actually a real word, right? So when you perform the stemming, you will be getting a stem word which may or may not be a real word, but you will try to find the base word among these different variations. That's what a stemming will do. For example, see here, changing, changed and change are converted into this format, and for example in this one also. So how to perform this? From nltk.stem you can import porter stemmer. So this porter stemmer, this class is going to help you to stem the words. Okay guys, clear? From nltk.stem import porter stemmer, and I'll create an object for it, stemmer equal to porter stemmer. Okay, so now I'll create new 2 equal to, now we are going to create another list where, so again for is it in words. So I hope now we got this list right. So we can go and take this one from new. So instead of words, I'll pass this list new, which now we have used to stop words to remove other things, right? So here stemmed underscore word equal to stemmer, and in this you can go for the option stem, and you want to pass the is it here because every word will be passed here. It will try to find the stemmed word. Okay, and I'll be appending them with the new list dot append stemmed underscore word. I'll run this. Now I hope we can get the stemmed word. Print new 2. See here, this word is not an entire thing, but it is tried to stem it, right? Climate, Cheng, okay? Some word will be as such, it cannot find the root word. Atmosphere, cause, global. So this is what will happen in Porter stemmer. So it will try to find the unique words based on the stemming, right? Finding the base word. And some advanced option of stemming is known as lemmatization. So this is similar to stemming, but some advantages there for lemmatization. So lemmatization is the process of reducing a word to its base form, which is called as lemma. Okay, lemmatization is similar to stemming, but it produces a valid base form of the word. Okay, so this is available in dictionary or vocabulary, not like this one which is not available. Okay, so this should be converted into change, right? Not chang, which is not even actually word. So this lemmatization will help you to find the base word which is actually present in a dictionary or vocabulary. The output of lemmatization is a word's base form or lemma, which can be real word or a root form of a word. For example, these things are converted into change. I hope you can understand finding the base word. It is done with the help of lemmatization. And to achieve this, you can go from NLTK.stem, import wordnet lemmatizer. Wordnet lemmatizer. Okay guys? So I hope we can try this one also to find the base word. From NLTK.stem, import wordnet lemmatizer. So I'll create an object lemmatizer equal to wordnet lemmatizer. Then what I have to do, tell me guys. I'll create new 3 equal to empty list for an. So we want to take, I don't want to pass this stemmed word into lemmatization. I want to pass this top words which I have completed. Okay, I want to pass this one to find in here. So I'll pass here new. Okay, lemmatized or lem word equal to lemmatizer dot lemmatize. Okay guys, I want to pass the a here. And finally new 3 dot append lem underscore word. Let me run this. So it is taking some time and it is completed. So I'll print new 3. See here, climate, we got an entire word, right? So it will try to achieve the base word if it is in some other format, and that's what this pre-processing will help us to do. Okay guys, these are some of the basic pre-processing you can do when you're dealing with the text format. And are we clear till now? This is the basic pre-processing you can do, and next step will be converting them into numerical format, where we'll be going for bag of words and TF-IDF factorizer. So I should need a confirmation from you guys so that we can continue with the next part. I hope you can understand why we are doing this process to reduce the noise actually and take important information from the text. So I'll tell you guys some of the applications of this NLK. For example, there are some data science projects. For example, like customer review, or we are having tweet analysis, sentiment analysis, and some other tasks like that are available. So we are having movie review, and that things. So if you are having Amazon, the product review, how the customer reacted to it. So you are having a bunch of huge amount of data. This is just a simple paragraph I am using, but you will be having data sets where you will be having each person's tweet. For example, you will be having many data, thousands or 10,000 or lakhs or crore amount of data. You want to take the important information, so that's why we are doing this pre-processing to reduce the noise and take the important information. So now we have done some basic pre-processing and we want to go into converting them into numerical format. So how are we going to do? First, we are going to see an option which is nothing but bag of words. So bag of words is a simple text representation technique used in NLP to convert text into numerical format that can be processed by a machine learning algorithm. So once you've done it, you can actually give it to the machine learning model to do further processing, whether it can be a classification problem like that. Okay. So what is this bag of words will do? If you are passing a list of words actually, so it will try to find the unique words and take it, and actually it is doing value underscore count, right? So how much that word is repeating. So based on it, it is going to convert them into numerical format. So it is done with the help of sklearn.feature-extraction.text import count vectorizer. To achieve this bag of words, we are using count vectorizer, which is from scikit-learn, right? This we have used in machine learning, right? So in sklearn, we are actually using this feature extraction, okay, for text. We have used this feature extraction, right? For which purpose we have used it? For PCA we have done it, right? For text we are importing count vectorizer. So I hope we can start with this one. From sklearn.feature_extraction dot text, in that text actually import count vectorizer. Count vectorizer equal to, I'll create object count vectorizer numerical format equal to, so this CV dot, you can use fit underscore transform option, guys. And another thing, guys, before going into this, now we have done the pre-processing. Okay, our paragraph we have split it into tokens and we have done our pre-processing, and it is time for us to combine them. Okay, so this now it's in a list. I want to combine them into a sentence now, where I have took the important words and I want to combine them into a sentence again. How can I do it? I can do it like I create a variable new sentence equal to, using string dot join option with space. I'm going to join each of them. Dot join, I'll pass this new 3, because you can pass it as a sentence here. So if I print new sentence, it will be in a sentence format, not a list. So this is a method you can combine a list. See here, now I got back my string sentence or paragraph, for example. Okay, now I'll pass this one new underscore sentence. I'm going to fit and transform them. Okay, so once I done it, I'll just turn them into array for our purpose, to array. Okay, we got an issue here. We'll try to fix it. Okay guys, I hope we have to convert this into a sentence, I think so. So this, I'll just try to do another thing. Again in this variable new underscore sentence, I'll call NLTK dot sent underscore tokenize. Okay, we have to pass it as a sentence, I think so. We'll try it. New underscore sentence. Now I hope it will run fine. Yeah, okay, my bad. So the thing is, you can pass it as a sentence, guys, totally. Okay, not as a paragraph, you can pass it as a sentence. So these words I have just converted them into a paragraph, and then now I have turned them back into a sentence. Okay, so I can print them, actually print new underscore sentence. So those will be individual sentences. So now that we have passed into this transform count vectorizer, which will turn them into a bag of words. Okay, I'll print this. You can see what it is. So this is the array we got, guys, 0 1 0 1 in this format. This is like basically like one hot encoding. So for our input features, okay, it has turned them into this format. This can be now given to the machine learning model for further processing. Okay, so if you are having a data set, for example, like in each row you are having some tweet, for example. So what you are trying to do, you are trying to stop the base word or stop words, remove them, take the lemma using lemmatizer, and then what you are doing, you are actually passing it into bag of words where it is converting into numerical format. Now in your data set, for example, or imagine this example, guys, you are going to create a spam classifier. This is done with the help of NLTK, and you are having a data set where it will show whether that word is like that mail, that content is spam or not. Okay, it is a classification problem. So in that data set you can convert them into numerical format like this, and you can train the model based on the target column whether it will say whether it is spam or not spam. So now if you give a new data, new text, it will try to identify whether it is a spam or not. We'll try to do that project in tomorrow's class actually, so that you can actually understand why we are doing this process. Clear about bag of words, what it is doing? Clear, guys? And some advanced version of bag of words is nothing but TF-IDF. Okay, so this bag of words will just count actually how much it is present, and it is converting them into numerical format, but this is not adding any weight or importance to it. So for that we are going to something known as TF-IDF vectorizer. So what it is? Term frequency inverts document frequency. So this is what is a technique used in NLP to reflect the importance of a term in a document. You may be having many words, but you want to find the important words, or you want to add the weight to it, like we did in neural networks, right? So the term frequency, this term frequency TF is a measure of how frequently a term appears in a document. Okay, and the inverse document frequency is a measure of how rare or common a term is across the entire corpus or your data. So TF-IDF is a calculation weight of a term is calculated as the product of its term frequency and TF-IDF. So TF is a calculation, guys, IDF is a calculation. Finally you are just multiplying. Okay, so the formula will be like this, where you are doing the dot product. The term frequency is the inverse of document frequency. Okay, how much it is. Like for example, if you pass a sentence, it is going to split them into words, and it will give you how much it is present based on the importance we are having this weights, guys. Clear? So instead of zeros and ones, now you will be having float values which will actually determine or give you the importance. So that's what somewhat advanced, guys. Now you'll be having some more advantage to find very important words, give more importance to it, right? I hope you can get the idea behind this. So this can be done with the help of TF-IDF vectorizer from feature extraction.text from sklearn. I hope we can continue with this one. From sklearn.feature_extraction import TF-IDF vectorizer. Where did I made a mistake? sklearn.feature_extraction okay, it's from .text actually, I missed it. Import TF-IDF vectorizer. So TF equal to, I'll create an object TF-IDF vectorizer. So I'm going to do the same. I'm going to fit and transform it. So TF_result equal to TF.fit_transform. I'm going to pass that new underscore sentence. I hope that is the name I have given, and I'll convert them to array. So now I'll print this TF_result. So which should give me an important words based on the weightage, right? Yes, thank you. Dot text, I have completed it. Thank you. So see here. So now we got zeros, and based on the weightage we got some numerical values. So this will help us to furthermore give importance. Okay guys. So that's what the difference between bag efforts and TF-IDF vectorizer. Term frequent, inverse document frequency. So this will help us to do the pre-processing, and now this can be split into train and test part. Okay, with the output you can match it and give it to the machine learning model, which we are going to cover in next class. Okay, we are going to see that project actually. So with the project you can actually learn more, and we'll also try to include the RNN so that we can learn about RNN, how to do that processing neural network for text data. And another important thing, when we go for project you have to go with regex, guys. So actually when you are dealing with text data, there is something known as regular expression, which many of you guys may know. Okay, this is like finding some patterns. With the help of patterns we are trying to extract information from the text, and this will be handy in case of many things. For example, imagine you are handling a Twitter sentiment analysis. It is a data science project, and your data set has the tweet information. Okay guys, whether it's positive tweet or negative tweet, something like that, or neutral. And in your data multi-class classification problem, and in that text you are having the tweet, one single row you are having the tweet of users, but it also has hashtags, it also has the username. Okay, how you need to remove them, but you cannot go and remove them in one by one. Okay, you will be having 10,000 rows. How are you going to do? You can use regex. Okay, first I need to remove the hashtag. So how can I do? So there's something which starts with the hash symbol. I don't want it. I want to find them. Once I find it, I want to remove them and take the remaining text. How am I going to do? So using regex you can do it. So what is regex? Regular expressions, commonly abbreviated as regex, are powerful and versatile tool for working with text data. So a regular expression is essentially a pattern of character that describes a set of strings. With regex you can search for specific pattern of character within a larger body of text, replace them and extract specific information from the text data. You can use it from Python. It is from import RE. You can use this regular expression, and these are the options which is available. You can search them. You can pass the pattern. So this pattern will be like something like this. So I'll give you a glimpse about it. You can search them. You can find. Okay, you can substitute. Okay, you can do all these operations with regular expression. And in regular expression, a pattern is a sequence of character which is used to identify some of the pattern from your input text. So if it is matches, you can do further processing with it. Okay, this is something like it may have. So you can actually find some text or numerical format or symbols. Like if you are going to find a mail ID, you will be having at the rate, right, in the end. So at somewords.com. So like this you can define them. What is a pattern? For example, if you are importing regular expression, this you will be specifying some pattern here. You will be having the input text. You are going to find all of them, which is including this pattern. So you will be passing pattern and the text, and you can replace them in further processing. So some of the regular expression anchor, like some of the tasks here, you will be having anchors. So this will help you to something present in the start of the line. Okay, and this will be for something in the end of the line. End of a string. Word boundary, if you want to find a word without any spaces. Not a word boundary, the capital B. This will define start of a word, this will define end of a word actually. And you are having some character classes like white space for small s. Okay, small s, capital S means opposite, not white space. If you mention small d, it will be digit. If it's a capital D, it will be a not digit. If it's small w, it's a word, and if it's capital W, you are going to use a not word. So you'll be having this backslash actually. You want to mention it. And you can mention the ranges also. For example, if you mention a dot, it should be actually any character except a new line. If you want to mention something like this or that, you can go with mentioning inside parenthesis, and you can go and mention this or operator, A or B. Okay guys, if you want to find something like this, A or B or C, you can go and give it in square bracket. And if you mention this caret inside of it, which mentions not any of these, and if you mention this outside, actually it is nothing but start of the line. Okay, if you want something from A to Q, you can actually mention this inside so that it can get from A to small q. You can go and get this from capital A to capital Q, or number from 0 to 7, you can go there. This n sub pattern. Like for example, when you see it here in this pattern, actually I have mentioned anything which is in the small letters, in the capital letters, and from 0 to 9 to actually match this one. And something like quantifiers, if you mention star, it is like 0 or more present. Okay, if it's question mark, it is like 0 or 1. So if you want to find whether it is 3 times repeated, so you can go and mention this inside curly braces 3, which will find for exactly 3 times. If I mention like /w 3 times, it will find words which is only 3 times repeating. 3 or more, you can go with 3 comma, which means a lower limit and no upper limit. You can give the lower and upper limit also, and you can find it whether it is present or not. 0 or 1 times you can get it. And some of the examples, maybe you can find whether letters, okay, date or any format, number, hexadecimal code, email address, HTML, password. Okay, for example, when we deal with the Twitter dataset, we'll try to incorporate in any of the tomorrow or day after tomorrow's project, where you can actually remove the hashtags and etc. Okay guys, so these things are very important, including regex and what we have seen in the previous. Okay, converting them into numerical format. We'll try to apply them in project in tomorrow's class, guys. So that's it for today. Thank you. Thanks for watching. If you guys have any doubt, you can ask it now, or else I hope we can wind up today's session. So we have just seen the basic introductions of NLTK, NLP. We'll try to accommodate a project in tomorrow's class based on NLP. And make sure you are preparing for the project. Actually, you can register it. So that link will be circulated tomorrow. Please register and try to win the prize money. It should be based on data science, not any other field that will be neglected. So that's it guys. Thank you. Thanks for watching. And update 3, assignment 3 update link is available. So make sure you are updating it. And if you want to give a review, you can actually, that link is below. That's a LinkedIn post where you can go and in the comment you can give a review. And you can thank the people of Naan Mudhalvan who are responsible for making this classes happen. Many of you guys have done it in yesterday's class. Thank you. Thanks for giving your response. So that's it guys. Thank you. Yes, we'll try to incorporate Hugging Face also in further classes. When we see project, we'll try to imply that too. Okay. So in the next 2 days, we'll be seeing actually projects. So there we need to incorporate few things guys. So one will be a NLP project, which actually it can be, I'll try to cover whether it is spam classification or Twitter sentiment analysis, where we can use the machine learning algorithm and we want to use the neural networks. Actually, we have seen about CNN in yesterday's class. We want to incorporate RNN also, like LSTM, where you have to do word embeddings and so on. We'll try to do that and we'll try to incorporate this also. Yes, actually, in many places, not actually in that. Okay, email ID, you can search furthermore and learn more about it. For example, in like particular email ID, you can use regex, or for example, in password, actually, in password, it is telling you, right, you need to enter a capital letter, a small letter, a number should be there, a special character should be there, and this should be in the length of 8 actually minimum. So all these things, how it's done? It's done based on regex only. So many of the text features are done with the help of the regular expression only. So if you are interested, you can learn more about it. It's very difficult and interesting also. So it can do many things, like entering correct email ID. It can check the password. So using regular expression, there are a lot of applications in NLP. So that's it guys. Thank you. Thanks for watching. See you in tomorrow's class.